It's not actually the ideal voltage supply. It's actually the supply that you provide as with the internal resistors in series. Okay, so that's why we have not used it as the ideal voltage supply. So what is the formula of this? As this is connected in series, so this true voltage you will get after subtracting the voltage drop across your internal resistance. So then you will see that what is the voltage here. So we will check it in our circuits too, that how it happens. So I actually told, so this is the total voltage. You will minus your drop across the internal resistance, and that will be your output voltage that you are getting from the battery. So the voltage of the battery decreases as the output current increases. Means that as if you connect a very low resistance, your voltage of the battery also decreases. Voltage of the battery also dissipates over time as its internal resistance increases due to the buildup of internal reaction. What it means that if you connected a battery across resistors for a long time, so you should expect a voltage drop across your battery, okay? And error between the model and real voltage divider can be calculated, okay? So this is using the above equation. So what we will do here, we have a battery holder that connects our 1.45 volt AA size batteries in series. So we are getting at output 3-volt battery. So the battery, the voltage that we are measuring out at the output of the battery holder is 3 volts. And that is your open circuit voltage, okay? Which means, let me see if I can draw here. Mm. Just a minute. Or maybe I can open the can you see this slides now?
Yeah, the procedure 3. Now we
No,
can't.
no.
It just went off.
Yes. So yes, so these slides I wanted to show procedure 3. Yes, so what I was saying that what you need to do, you can see in this equation that this will be your VOC. VOC is the voltage that you will measure across the open terminal of your battery. That is your open circuit voltage, okay? So idea is we want to measure the internal resistance of the battery. So then after seeing VOC, what we will do, connect the 2 batteries with 1 kilo ohm resistor and measure the resulting voltage and record the values of this voltage and the measured value of 1 kilo ohm load resistance, okay? This should be kilo ohm. To avoid discharging the battery, do not keep the load resistor connected to the batteries any longer. So what you will do, you will measure the resulting voltage across 1 kilo ohm after connecting the battery. Now you need to calculate Ri of the battery from the loaded voltage and VOC. So you know Ri will be equal to VOC minus V, right? IRI this will be equal to this, okay? So this will be your voltage drop. Then you need to test simple battery model by loading the real battery with number of 5 different load resistance that you have and noting the resultant voltage. Keep the load resistors connected to a minimum period of time to avoid discharging the batteries, and compare the measured voltage with the voltage predicted by the model, okay? So, okay, so if I want to measure my internal resistance, so I can see the current in the circuit as well. So this current I can divide by this, and this will give me the internal resistance of the circuit or of that circuit. Okay? Is it clear?
If you could you like after this class re-upload this again with this with the red pen on top?
Oh, okay. So I will upload this PowerPoint as well. Okay, because I have uploaded the PDF. Okay.
Yeah, thank you.
Okay. So what I want you guys to do to start doing building the circuit. Okay, you don't have to do all the procedure, but you need to connect the circuits in series first, connect your 9-volt battery, and for each procedure you need to do at least your first step. Okay, so you need to do this step, like start with the lab 1 circuit and calculate the output voltage. Here you're at R2. Where is the pointer? So this voltage you need to calculate, and then you can change resistors afterwards. Okay, but I want to see that you are able to make the this circuit on your breadboard. Okay, and similarly then for the parallel resistance, I want you guys to connect the resistors in parallel, check its current and voltage both. Okay, I know this is not 10 volts now, this is 9 volts, so you need to check the current and voltages. Okay, and you can only do the first part of it, and then you can afterwards do the when you have to connect another resistor in parallel. Okay, and similarly I want you to check the output circuit voltage and the voltage after connecting the battery. Is it clear? So that I can help you if there is a problem in connections. Okay?
Sounds good.
Okay.
And just be careful with the battery. So start doing the first part and I'll be here. I just, in the meantime, want to check the equivalent resistance. So I want to show this to you. So if you see, this is my multimeter. Okay. And if you see, this is how I connected the two resistance in parallel, and without connecting any supply, I will check their equivalent resistance. Okay? Is it making sense?
Yeah.
So if this is 1K ohm, what should be its equivalent resistance after connecting them in parallel?
500.
500. Yeah.
Yes, it should be 500, right? Can you see the multimeter? So it is showing me 497 something. Okay, so it's right. So that's how you can calculate your equivalent resistance by connecting it in the circuit. Okay, so I will stop the video and I will let you guys make the circuit, build your circuit. So do you all have your equipment now? Can you all build your circuit, or is there anybody who is not building the circuit?
I don't have it yet. So what I'm gonna do is I'm probably gonna go to the store tomorrow and buy the components myself.
You didn't get the kit yet?
No, and I doubt it's gonna get here. So I'll just ask like one of my friends to send me a picture with all the components, and I'll just go to an electrical shop and buy them.
Yeah. Okay. Because I'm not sure about the international deliveries, right?
Yeah, because it'll probably get stuck at customs. Like, I doubt it's ever gonna get here. So
Oh yeah. Okay. Yes, that's I think a wise approach because otherwise you will keep missing your labs, right? Okay, thank you. And I want you guys to include the picture of hardware um, in lab. So include the picture of the hardware for the series circuit, for the parallel circuit, for the current measurement, for the voltage measurement, like every step in which you are changing your circuit, okay? Because I want to see how you are learning this, because this lab is supposed to be a practical, right? So that's why we want to make sure that you are learning the practical aspects of circuits.
You just want the circuit, or do you also want the multimeter in like the picture, like the value that we got? Because it's kind of tough to take a picture
I
like
know,
that.
I know. It's up to you. Okay. I really want the circuit. So multimeter, I trust you guys. But if it is there in the picture, it's good. Okay. So if you are saying this is my reading, it's okay. I trust. But if you can include, it's a plus. Okay.
All right, sounds good.
Mhm.
Do we have to add any pictures for the last lab?
No, it's okay. I didn't tell you, so it's okay.
Okay, thanks.
Does the battery need to be connected in the pictures we upload?
No, no, I did not include the battery. If you have noticed, I think in one picture, maybe the battery is connected, but in most of them, it's not. But if you are not connecting the battery, then your circuit should be very clear that the red part, that red wire you are using for the positive and black you are using for the negative, because some of the students are not following the signs. But if you are including it in the picture without connecting the battery, then it's important to follow the signs. Okay.
Okay.
Okay, so I'll let you guys make the circuit and you can show me one by one after connecting it. And you can ask me any question if you have.
I think mine's ready if you want to see it.